we are doing our part D, which says f of theta is equal to sine of theta squared, or the squared is in sine, then times cos 3 theta. Now we want to differentiate this. Well, what we just can see is we have two things multiplying, so we have to use the product rule, okay? We have to use the product rule. And now since I can see I have something inside here, this is going to be, again, chain rule, because I have a theta squared. If it's just sine theta, then it's the normal one. But once you have something which is not theta, then it's the chain rule. Like here, I have 3 theta. That's not a theta. So I have to use chain rule again here. Now you can do it the shorter way, or you can do it the longer way. We can start by doing it the longer way to say, you can have for the derivative d theta of sine theta squared. What would you do here? Okay. You can say for the derivative, which is d theta, it's in terms of theta, right? So for the derivative of sine theta squared, you can do it to say, I'm doing this part first, okay? What would you have? What is the derivative of this guy? Well, you'd say, let u be equal to theta squared. And now you can have it as y will be equal to sine of u squared, okay? No, sine of u rather, because theta squared is the u, so it's sine of u. Now we'll be saying du d theta is going to be 2, it drops down, it becomes 2 theta. Then we can now say dy du, okay? You can even say let y be equal to sine of theta squared, this first thing. Then now you can say for this, you can you've made y is this. You can even just write to say y is equal to this, right? Then you can now say let u be the inside. Let u be the inside, which is this theta squared, and you can that means now y is sine u. You should have said something about y to know that it's this part. Now here, what is my dy du? Derivative of sine is positive cos, so it's cos u. Now I can then say dy d theta, because y I have it in terms of theta here. This is going to be equal to dy du times du d theta. I'm sorry, I'm going the long way. What is my dy du? It's cos u times du d theta is 2 theta. This becomes 2 theta cos u. And what was my u? U was theta squared. So now it becomes 2 theta cos of theta squared. Okay. I'm going to do it the shorter way. Okay. I'm doing it the longer way first, which you don't have to do this long way. Okay. Doesn't really help. Now we are now doing for the derivative of this part, cos 3 theta. Okay. So which I don't know why I'm even doing it the long way. So we can say for d theta of cos 3 theta, because it just makes everything be long, because now you can just say here y is equal to cos 3 theta. So you say now let u be the inside function, which is 3 theta, and y is now cos of 3u. I don't want you to do this longer way. Okay, I'm going to show you the shorter way, but I'm just doing it so you see what we could have done if we had done it the long way. Du d theta is just the derivative of 3 theta is 3. Then dy du, this is just going to be the derivative of, let u be, so y is now cos u, because 3 theta is now u, so y is now cos u. Derivative of y is negative sine, and it's now negative sine u. So now we can say dy d theta, because y is in terms of theta. This is going to be dy du, the new one, times du d theta here. So this is dy du is negative sine u times du d theta is 3. So it becomes negative 3 sine of u, which is u is 3 theta, sine of 3 theta. Then now I can then say, this is now very easy for me, because I have f of theta. Now I can come back and say f of theta is going to be equal to, we have what as my f of theta? Sine of theta squared multiplying cos 3 theta. I mean, doing it this long way just shows you what it could have been, so that when you see, you can see why we like to stick with the shortcuts. It really helps, because you could spend the whole day. Now here you can say let u be equal to, now we are doing the product rule. We know the derivatives now. Let u be sine theta squared. Then v is now cos 3 theta. U prime is the derivative of sine theta squared, which we just got. The derivative of sine theta squared is this 2 theta cos theta squared. So this will be 2 theta cos theta squared. Then v prime is just going to be, we just got this derivative, is negative 3 sine theta. Negative 3 sine 3 theta. So now we can just come and say that if prime theta is going to be, what is it? The second v times the derivative of the first u prime plus the first u times the derivative of the second v prime. Okay, that is how we differentiate this, because it's product rule. So now we can say, what is the second? What is v? It's cos 3 theta times u prime, which is, it's going to multiply negative 3 sine 3 theta plus u, what is my u? Sine of theta squared multiplying v prime. Multiplying v prime. Oh, did I multiply u prime? No, something is wrong. V times u prime. U prime is this. So this should be 2 theta cos theta squared. Okay? 2 theta cos theta squared. So this would now be times v prime, which is the one here, negative 3 sine 3 theta. So what am I going to have now? This becomes cos 3 theta times this. This just comes 2 theta. Then you have cos theta squared cos 3 theta. Plus here you'll be having, this becomes a negative. So because there's a negative, negative 3, then sine theta squared sine 3 theta. This is going to be your final solution, and you are done. Okay, this is going to be your final solution, and you're done. Now let's see how we would have done it the shortcut way, which is not easy. It's not easy, but it's still fine. F of theta is equal to sine of theta squared cos 3 theta. So what am I going to see? I'm going to see that these two things are multiplying. Okay, so I can say let u be equal to this first thing, okay, which is sine of theta squared. Then I can say v be the second thing, which is cos 3 theta. Now let's find u prime. Can we find u prime? Yes. What is this? This is a function of a function. We can see that there's something inside or something outside. So how do I get a function of a function? How do you differentiate something when it's like this? When it's a function of a function, something inside of another function. It's something which is not a theta. Once you see something which is not a theta, okay, remember, what are the different types of composite functions, which is a function of a function? It is, for example, if you have y being equal to 3x plus 5 to the power of 7. This is a type of a composite function. There's a function inside and a function outside. Or if you have something like y is equal to e to the, then we say to you x squared plus 5 or whatever. Anything which is not an x, because the original one is just y is e to the x. Once it's no longer an x, once it's something which is not an x, then it's a composite function. Or if you have y is equal to cos of 3 theta, this is a composite function. It's supposed to be cos of theta for the normal one. Now it's something which is not theta, so it's a composite function. These are the different types that which we're just showing you. Either way, now what we'll be saying is, how do? I have something which is not normal. So what do? I differentiate the outside first. You start with the outside whilst ignoring what is in the inside. So what is the derivative of sine? It's positive cos. So derivative of sine is positive cos, and it's still theta squared. You don't touch it. Okay, you don't change whatever was on the inside. You just differentiate the outside. Derivative of sine is cos of the exact same thing. Then you multiply by the derivative of the inside. So you do the derivative of outside times the derivative of inside. Derivative of outside without seeing the inside, then you multiply by the derivative of the inside. What's the derivative of the inside? Is the derivative of theta squared. You bring down the power, it becomes 2, you reduce it by 1, it's theta to the 1, which is just 2 theta. And this becomes 2 theta cos theta squared. Then here we can now say, since we had our v, we can move it down a bit to say that v is equal to cos 3 theta. Same thing now, let's practice. Derivative of the outside times derivative of the inside. So what is v prime now? Derivative of the outside, which is the cos. The inside is this 3 theta. Derivative of cos is negative sine. Of what? Of 3 theta. You don't change the... Then you then multiply by the derivative of the inside. What's the derivative of 3 theta? It's just a 3. So this becomes negative 3 sine 3 theta. And you can see that this will be the exact same answers as the one you got here and here. Okay, same answers without having to do that long way. So where did we start? We just started here. We had our f of theta. You write out your f of theta. So this is the part B. This is another way. You have your f of theta. So what you do, you let u be this, v be the second. You get your u prime, then your v. Then now you can say f dash of theta, the first derivative, is just equal to second thing, which is v times u prime plus u times v prime. And you can just bring it, okay? Second times the derivative of the first plus the first times derivative of the second. Remember, there is a plus. That's your product rule. So you can now just bring them as they are. You get the same answer as the one which we just got. So v is cos 3 theta times u prime, which is 2 theta, this one, 2 theta, then cos theta squared, okay? Then plus u, what is u? Is sine theta squared. So it is sine theta squared times v prime, which is v prime is negative 3 sine 3 theta. So what are we going to get? This now just becomes equal to, here we have 2 theta, and it is going to be cos 3 theta cos theta. We can start by cos theta squared, then cos 3 theta. Plus, oh, this is a minus because there's a minus here, minus 3 sine theta squared, then sine 3 theta. Here is your final solution, which is just like that other one. And you would be done. You understand? This is the shortcut. Be able to do this the last week, which I did it. Goodbye for now. See you in the next one.